Welcome to another Mathnificent conversation. It's your nerdy math bestie Lex. Today's conversation is featuring rationalizing the denominator when the root is an integer that is greater than 2. I've already done a video rationalizing denominators where the denominator is a square root. This video is going to focus on roots that are bigger than 2. I would suggest you check that video out first. I would also suggest you know how to simplify a radical, and I would suggest you know what a prime factorization is before you dive into this video. So grab your pencils and let's go. Our first example, we're going to simplify 5 over the cube root of radical 2. Now, I've already explained in math, you can multiply any expression by 1 and it will remain an equivalent expression. The important part is knowing what that 1 is going to look like. So right now in our denominator, we have the cube root of 2. We know if we want to simplify that so there's no longer a root, it needs to look like this. I need the cube root and then I need 3 2's because that's how we simplify a radical. Once I have 3 2's under a third root, I now have 2. So we know this expression is equal to 2. Well, I have 1 2 in my denominator, which means I need 2 more. So I need the cube root and I need to multiply it by 2 more 2's. But I know I can only do that in the form of 1. So I know I multiply by a fraction that's equivalent to 1, but gives the desired outcome in the denominator. So now in the numerator, I have 5 times the cube root of 2 times 2. And then the denominator, I have the cube root of 2 times 2 times 2. Because it's a cube root, I know if I have a triplet of 2's, they come out as a single 2. So in the numerator, 5 cube root, I can go ahead and multiply 2 times 2 because I don't have 3 of them. So it doesn't simplify, it just becomes 4. And then the denominator, I now have 2. I always double check, can 5 over 2 simplify? And it does not. So my final answer is 5 times the cube root of 4 divided by 2. Let's go back and assume you didn't see 9 as 3 times 3. Because that's okay. You just end up with more work in the end. So 6 over cube root of 9. So now we know we need 2 more 9's to make 3. So we'll multiply by the cube root of 9 times 9. Cube root of 9 times 9. Okay, so at the top, we know this is our equivalent form of 1. At the top, we have 6 times the cube root of 9 times 9 all over the cube root of 9 times 9 times 9. Now, in the denominator, my triplet of 9's will come out. But in the numerator, I have to do more work because my 9's will each break down into 2 3's. This is equivalent to 9, and that's equivalent to 9. Now I have a triplet of 3's that will come out as a single 3. And in my denominator, I now have 9. So now I have 6 times 3 times the cube root of 3 all over 9, which is equivalent to 18 cube root of 3 all over 9, which is equivalent to 2 cube root of 3. So we still arrive at the same answer, but it took a lot more steps. So try to practice seeing a number as its prime factorization, because if you do that, simplifying and making sure you have the most simplified answer will be a lot easier. Okay, let's work on cube root of 7 divided by the cube root of 5. Remember, it's the denominator that we need to rationalize, not the numerator. So right now, 5 is already prime, and I have 1. So I know we need 2 additional 5s. And I need to do that as an equivalent form of 1. In the numerator, now we have 7 times 5 times 5, all of which are prime, so I don't have to break down any further. And in the denominator, I have 5 times 5 times 5. I have a triplet of 5s that will come out as a single 5. Because 7 and 5 and the 2 5s are both prime and I don't have 3 of either of them, I just go ahead and multiply, and that's 175. We know that won't break down at all. And my 5 comes out of my root. And that is complete. Okay, this one's a little bit more complex. We have 2 times the cube root of 10 over the cube root of 4. Remember, I always want to see this. If the numbers are not prime, I want to look at them as a prime factorization. Okay, if I want to rationalize the denominator, I have 2 2's, so now I know I need 1 more cube root of 2. And I know I can only multiply it as an equivalent form of 1. So now at the top, we have 2 times the cube root of 2 times 2 times 5 all over the cube root of 2 times 2 times 2. In my denominator, I now have a triplet of 2's that can come out of my radical. At the top, 2, 2, and 5 are all prime, and I don't have 3 of either of them. So I just multiply, and that becomes cube root of 20, and then 2 at the bottom. 2 divided by 2 I know is equivalent to 1. So my final answer is the cube root of 20. Again, if you didn't see the cube root of 4 as 2 times 2, and you went ahead and multiplied by cube root and 2 additional 4's, you can also do that. Just remember, you'll have a lot more simplifying at the end. Okay, let's take a look at some larger roots. So now we have 7 divided by the 5th root of 27. We know 27 isn't prime, so we're going to start by breaking it into its prime factorization. 27 is 3 times 3 times 3. Well, if I have a 5th root, I know I need 5 3's to rationalize that denominator. So I know I need the 5th root with 2 additional 3's, and I can only do that with an equivalent form of 1. In my numerator, I have 7 times the 5th root of 3 times 3. In my denominator, I have the 5th root of 3 times 3 times 3 times 3 times 3. I now have a group of 5 3's, so I can bring those out as a single 3. So I have 7, 5th root, and I'm going to go ahead and multiply 3 and 3 because I know I don't have 5 of them, and they're both prime, all over 3. 7 over 3 does not simplify any further, so my final answer is 7 times the 5th root of 9, all over 3. All right, we've reached our last example for today. 10 divided by the fourth root of 8. 10 isn't in a radical, so we're going to leave it as 10. But we're going to do a prime factorization of 8, and 8 is 2 times 2 times 2. So my root is 4. That means I need 4 2's in order to rationalize that denominator. So I know my equivalent form of 1 is going to be fourth root of 2 divided by fourth root of 2. So 10 times the fourth root of 2 all over the fourth root of 2 times 2 times 2 times 2. I now have quadruplet 2's, or a set of 4 2's. So now I can take those out of the radical. And I'm left with 10 fourth root of 2 divided by 2. 10 over 2 simplifies to 5. So my final answer is 5 times the fourth root of 2. I hope this video was helpful. Always remember you're magnificent and you're brilliant, and I hope to see you in the next video.